Hello, my dear boys. Good morning, everyone. This is your physics class, and we are starting chapter 9. The name of our chapter is Refraction of Light. And this is your physics teacher, Shajib Bishas, lecturer, physics, St. Gregory's High School and College. Today's topics. Today we will discuss on formation of different type of image by a convex lens part 2. In our previous class we have discussed this topic for first three position of the object, and in this lecture we will discuss another three position of the object for formation of image by a convex lens. And another topic is relation between u, v and f, which is generally known as general equation of lens. Another topic is magnification, and then we will also discuss on power of lens. Okay, so let's boys discuss these topics step by step. So today our first topic is the position 4, where the object is placed between center of curvature and focus point. So this is the figure for this position. Here you see that the AB is our object, and which is placed between focus and center of curvature of the lens. Okay, so a ray of light AO, which is parallel to the principal axis, after refraction pass through focus F along the direction FO or OF. Okay, while the other ray AC pass through the optical center C and goes straight without any deviation. These two refracted light rays intersects each other at point A prime beyond the center of the curvature 2F on the other side of the lens. Okay, so in this case the image is A prime B prime. You see the image is A prime B prime, and this image is larger than the object, and this image is real and also inverted. Okay, so this is our ray diagram, and the result of this image is position of the image is between center of curvature and infinity, or we can also say that beyond the center of curvature. Okay, and size of the image is magnified, and nature of the image is real and inverted. Okay, in our previous class we have discussed what is called real and what is called inverted. Here real image will be real when the image is formed opposite side of the object. Okay, here you see that AB object is placed in front of the lens, and the image A prime B prime is situated in the behind of the lens. Okay, so this type of image is called real image, and you see that the direction of image and object is opposite each other. So this type of image is called inverted image. Okay, so our next topic is when the object is placed at focus point. Okay, for this position of the object, you see the ray diagram in the slide. Okay, here AB is our object which is placed at the principal focus F. A ray of light AO which is parallel to principal axis after refraction pass through the focus along the direction OX. Okay, and while the other ray AC pass through the optical center and goes straight without any deviation along the direction CY in the picture. Okay, in this case, as is clear from the figure given below, that both the refracted rays OX and CY are parallel to each other. So these rays cannot intersect each other. Hence, the image will be formed at infinity. Also, if you extended this two parallel ray in behind the lens, then it will also be parallel. So there will be, hence the image will be formed at infinity. Okay, so that is why the image A prime B prime formed in this case will be highly enlarged, real and inverted. Here the image will also be virtual and erect. Okay, if we extended the two refracted ray behind the lens. Okay, so the result is position of the image at infinity, size of image highly magnified, and nature of image, here the nature of image will be real and inverted, and also can be virtual and erect. Okay, so our next topics, when the object is placed between focus point and optical center. Okay, so this is our ray diagram for this position of the object. Here AB is our object which is placed between focus point and optical center. Okay, so a parallel ray of light AO passes through the focus after refraction along the direction OX, while the other ray AC passes through the optical center and goes straight without any deviation along the direction CY. But in this case, the two refracted light ray such as OX and CY are diverging away from one another. So this cannot intersect each other to form a real image on the right side of the convex lens. Okay, thus the refracted rays OX and CY are extended backward by dotted line you see in the figure. On extending back, these rays appear to intersect at point A prime. Hence, the image A prime B prime formed in this case is a virtual image, which is formed on the same side of the lens behind the object. Okay, so here there is a new word which is virtual image, and the answer is the image is called virtual image when it is formed on the same side of the object or say or lens behind the object. Okay, and this type of image is called erect image. Why? Because the direction of the object and direction of the image is same. Okay, same direction, they are in same direction, so this type of image is called erect image. Okay, so for this position we get the position of the image is same side of the object, size of the image is magnified, and nature of image is virtual and erect. Okay, so this definition is very important here. Virtual image, erect image, real image, inverted image. This definition is very important for knowledge based question. Okay, so we will discuss with our next topic, and the next topic is general equation of lens. Okay, so here you see a figure. Here the object AB and A prime B prime is our image and F is our focus point. Okay, so here the red line is denoted the U, which is distance of the object from optical center. The green line is denoted by V, which is distance of the image from optical center, and the blue line is denoted by F, which is called the focal length measured from optical center. Okay, so boys, here optical center is very important for lens analysis. Okay, because all of the distance is measured from optical center. All of the distance will be measured from optical center for lens. Okay, so here the general equation of lens is 1 by F equal to 1 by U plus 1 by V. Okay, here sometimes V will be positive. V will be positive for real image, such as distance of the image will be positive for real image and distance of the image will be negative for virtual image. Okay, so boys, this is very important information for solving mathematical problem. Okay, so our next topic is magnification. Okay, so what is called magnification? Magnification of the lens is defined as the ratio of the height of an image to the height of an object. Okay, so here you see in the figure the AB is the object and A prime B prime is our image. So from the figure here, the length of the object is denoted by L and length of the image is denoted by L prime. Okay, so L is the length of the object and L prime is length of the image. Okay, so we can write the equation of magnification is M. Here magnification is denoted by capital M or small m. Okay, magnification is denoted by capital M or small m. Here the equation of magnification is M equal to L prime by L. Okay, or we can also write this equation as M equal to minus V by U. Here V is the distance of the image from optical center and U is the distance of the object from optical center. Okay, so here m will be negative when image will be real and inverted. Okay, m will be negative when image will be real or inverted, and m will be positive when image will be virtual and erect. Okay, so boys, this information is also very important for solving mathematical problem. Okay, so remind this condition very carefully. Okay, so boys, our next topic is power of lens. So what is called power of lens? Power of lens is defined as the inverse of focal length in meter of the lens. Okay, here boys, you must remember that for power of the lens, focal length must be in meter unit. Okay, if the focal length is in centimeter or millimeter, you must convert it in meter unit. Okay, so here the equation for power of lens is P equal to 1 by F. Here F or focal length will be in meter unit. Okay, so here P equal to power and F is our focal length. Okay, so the unit of power is diopter. Okay, boys, the unit of power is called diopter. Here diopter is denoted by capital D. Okay, so boys, this is all for today. In our next lecture we will discuss the defect of eyes. Okay, so until then, best wishes and thanks a lot.